sort of wish I wrote it like this instead. Dependent first. I swear I'll have my reasoning in a moment. And I use the slash mark. The slash mark in math is actually not just the slash mark, okay? So we have dependent and then we have independent. Something that's going to help us out a lot, especially when we start doing a ton of word problems, if you ever plan on taking calculus, okay? And you want to learn about optimization, you want to learn about related rates, you want to learn about these really cool topics. Well, you want to be able to dissect a word problem. You want to be able to read it, pick out, and pull apart the details that matter. If you think of this as a bit of a slash mark, okay, like a fraction bar, the dependent and the independent all have their role in the situation of talking about rate of change. What is a rate of change? So it's a little, like I said, I'm going to supplement in these videos. Rate of change. Rate of change is sort of a better way to describe slope. Okay, so this is usually applicable when you're dealing with word problems, okay? We would never say, oh, the slope of the car is 22 miles per gallon. What does that really say? Slope of the car, the rate of change, the rate at which the car burns gasoline, the rate at which the gasoline burns in accordance to how many miles, yada, yada, yada. The phrase rate is really going to help us out a lot more. Slope, sure, maybe slope is good when you're young, when you're in pre-algebra and algebra 1, and we can still visualize and understand that concept for years to come. But not all slopes are going to be really relevant as a rise over run in a graph, okay? Not all slopes are even constant. When you get to calculus, you learn a lot about changing rates. So I want you to think of slope as a rate of change. Now, another thing about slope, maybe you want to know the basic formula that we've used since our good old pre-algebra days. Maybe you think about slope as m equals y2 minus y1 over x2 minus x1. Change in y over the change in x. The word change really, really, really represents subtraction. Even when you get change from a cashier, you give a $20 bill for an $18 purchase, they give you back $2. Your change is the subtraction between the $20 you paid with and the $18 total, you get back $2. Change, subtraction, okay? Another thing about change in y and change in x, there's some notation you might not be too familiar with yet. The notation is using a Greek letter, delta, the capital D, essentially it's a triangle, delta y over delta x. So that notation, these triangles, really mean the change in y over the change in x. It essentially means what we have written right over here. Okay, now why is this mattering? Dependent and independent, okay? If I were to set up a quick little graph here, we can really have a nice conversation about rate of change. I kind of had a little brainstorm. So let's pretend you wanted to know, well, I want to analyze the miles driven on a trip based on the number of minutes that I am driving, okay? So you start your trip at mile marker 0. You have done no driving so far, okay? Now, let's say that in 15 minutes, okay, in 15 minutes, you had driven 7 miles. And you're going pretty steady. You think you're going pretty flat, constant. Constant means doesn't change. A constant number of miles per hour, okay? After 30 minutes, you check in, and now you've gone a total of 14 miles. You're at mile marker 14. After 45 minutes, that's another 7 miles in 15 minutes. You went 21 miles in 60 minutes. You have now gone 28 miles, and so on. And you continue at this pattern, okay? What can we say about the rate of change? What can we say about the slope? Well, usually you've been given these word problems where maybe you were just asked to find the slope. Maybe you were just asked to write the equation of the line. In the event you were asked to find the slope, you might have just plugged in this equation. Maybe you picked 2 ordered pairs. Now, it doesn't matter which 2 you pick. No, as long as you treat your x's and y's appropriately, you could pick either, whatever 2 pairs you want. You should get the same answer. So just to practice our math a little bit, I'm going to pick this one right over here, which is 60, x value first, comma 28. And I'm going to pick this one over here, which is 15, comma 7. Now, usually when we go to find slope, I feel like everyone just sort of pops things right into the equation, or if they have graph paper, they just want to kind of count out the boxes. But how helpful is that really going to be in the long run? So let's do some more investigating. I'm going to go ahead and fill in, and some of you may have to label x and y, but hopefully we can all keep up today. So I have 28 minus 7 in my numerator, and then I have 60 minus 15 in my denominator, and that gives me a 21 in my numerator. That gives me a 45 in my denominator. These numbers actually both reduce by 3, so I'll get 7 over 15. And if you had to write the equation of a line, everyone sort of from middle school may default to y equals mx plus b, which is not the name of this form. This is slope-intercept form. Here's slope, here's intercept, and the rest is x and y because those are variables. Those values can change, and we can plug in all different values. We leave it as x and y to indicate the entire line. We're kind of generalizing. Now, p is pretty easy to find in this example. It's your y-intercept, and my y-intercept in this example is a nice little 0. So the equation would end up being y equals 7 over 15 x plus 0. which obviously we don't even need to write. But if you don't pay attention to the units, if you don't pay attention to which thing is dependent and independent, do you really have a good understanding of what it is you did? Or are you just being a bit of a robot and writing the equation of a line? So let's say we looked at this and we kind of just shed a little bit of new light on it, okay? So this is sort of the old, just do it like a robot way. So let's look at this differently, okay? I'm going to find my slope again, but I'm not going to call it my slope. Instead of calling it slope, I'm going to think of it as my rate instead, like I mentioned before. Okay, now my rate still is my change in y over my change in x, but instead of calling it y and x, I'm going to think of it as the change in my dependent variable. What depends on the other thing? Change in dependent over the change in my independent. Okay. Now in this case, I'm more or less going to straight up tell you which one is dependent and independent, and in future examples, I'm going to ask you to tell me. So the number of miles driven depends on how many minutes you were driving. Really, I mean, sure, you could say you're going to interpret it differently, and that's definitely possible, but we're going to interpret it in this way. The number of miles driven is dependent upon how many minutes you have been driving. You set your car to cruise control, you let it just go. It's like, how far have we gone? Well, how long have we been driving? Okay, so your miles driven depends on the number of minutes you are driving. Now, when I find my rate, instead of just plugging in the numbers, I'm going to leave the units in. So I'm going to fill in 28. Now it's a y value, so this is 28 miles. Mi is miles, minus 7 miles. Treat the word miles or the abbreviation for miles like an x, like a radical 3, okay? It just sort of goes along for the ride over here. Really, we're sort of using we're using a distributive property to combine like terms because we'd factor it out, but that's another conversation for another day. And down in my denominator, I have 60. Now minutes minus 15 minutes. Next, when I'm done subtracting and reducing, okay, see, I already did it up there, so I'm going to cut ahead a bit. I have 7 miles over 15, because it would reduce, right? We already did the math up there, minutes. Now this is something I could wrap my head around a little bit more. What can I say about this? 7 miles for every 15 minutes. Even if you plotted this as a rise and a run, I go up 17, I'm sorry, not 17, I go up 7 miles in miles driven for every 15 minutes I have been driving. Up 7 miles for every 15 minutes I've been driving. Now, what if I kind of pull that 7/15 out? What else can I say about the rate here, okay? So if I pull that 7/15, I can look at it as 7 over 15. Miles over minute, well, you could even think of that as miles per minute. Your rate is another way of saying your speed, okay? Now, what if I wanted this to become hours? Well, I need my 15 minutes, right? Because right now I'm looking at it as 7/15. I need my minutes to really be 60, okay? How can I change that to 60? Well, in chemistry, you're going to talk about dimensional analysis if you haven't already. So I am going to show you a little other thing on the side. And like I said, these are all to supplement everything you're doing. I really want to boost the rigor of what we're doing and really make it a little bit more analytical, a little bit more intense so that you are equipped to handle anything, okay? Now, this is a fraction, a numerator and a denominator, and this is my fraction bar right there. This over here just represents that I'm multiplying it by another fraction. If you want minutes to cancel out, I need a certain number of minutes in the numerator that I'm multiply it by. But if minutes is going to, I shouldn't say cancel, I should say reduce or simplify. If I need minutes to reduce, I want to change it to hours. I need hours to be over here. And I need whatever's here to be equivalent. So how many minutes equals how many hours? Well, 60 minutes is equal to 1 hour. This is not an equal sign. It's essentially just multiplication. It's just a certain way of setting it up. 15 and 60 can reduce. This will become a 1 if that becomes a 4. And what do we get from this now? 7 times miles times 4. What does that say? Well, I can see 28 miles. 1 times hour. Well, that's just an hour on bottom. So you can look at your speed or your rate as 28 miles per hour. How is this going to be helping and benefiting you in a word problem? When a word problem tells you some sort of a rate or a speed or something that you can word or phrase into blanks per blank, okay? Puppies per household, all right? Miles per hour. Pints of ice cream per freezer. Whatever the rate, your numerator, your thing that is written on top, above or before the per or the for every, however they phrase it, this piece right there is your dependent, which will go on your y-axis. It's your change in y. And this is your independent. It goes on your x. It's your change in x. So a little bonus piece right there. Okay, your numerator and denominator are very significant. When you describe a rate, it is attached to the slope concept. So that's why I don't like that I wrote it like the way I had written, sorry, up here. That was just automatic. But really, if I wrote it like this, d over I, y over x, okay? Dependent is the y, independent is the x. Horizontal axis, vertical axis, rise, run. So if you need to write those things down for yourself, then go right ahead. If not, let's carry on and fill in some notes over here. The blank variable. The variable you have control over, the variable that is varied or manipulated, usually represented by blank. The other one is the output, response, or effect. So this is the one that you get out of a situation. So this is going to be our dependent, the output. If I use the word output for this, I could also use the word input for that. So let's fill in some pieces here. This over here is going to be independent. This one over here is dependent. Our independent variable is usually represented by X. Okay, we also attach this to the phrase input. It's what you put in the equation more often than not, okay? We also attach this to the concept of domain, okay? They're all kind of connected and related. Whereas here, dependent variable, we have the word output, usually represented by Y. Since we have domain there, I guess we could also write range, okay? What else could we say? That's one other thing maybe. This is a horizontal axis. We don't always use X and Y. This is your, the run, from your rise and your run. This will be our vertical axis. Vertical, C-A-L please. This is our vertical axis, and this is the rise, okay? And I'm just gonna circle output and input. So all these words correspond to that. And if you wanted to add that little note onto this, we could even say something like miles per hour, which is equal to MI per HR. Okay, and we just said this in your numerator, your rise is your dependent per, this is your independent. Okay, don't underestimate how helpful that's going to come in. Okay, like how handy. Graph the following information, label and number the X and Y axis appropriately. Okay. Number of hours of study and grade. I know in class we had like a nice conversation about this, how if someone's grade is really high, they might not study for a lot of hours. In that circumstance, you would see the number of hours be small with a high grade. So you really got to analyze it. And it was a good thing to ask about and a good thing to talk about. You want to make sure that you pay attention to the relationship, okay? Are things getting bigger? Are things getting smaller? Which thing is affecting which other thing? So you really want to analyze all of this. So in this case, I would say the number of hours of study is your independent variable. And the result, the thing that's being affected, is the grade. People who study for 0 hours might get a 20%. Study for 2, study for 4. And I wouldn't say in one night, obviously. I would say over the course of a unit. Grade depends on number of hours of study. Okay, so let's go ahead and make a little bit of a graph for this. And then we're going to answer these questions. So I made this little bit of a bar graph here. Sorry, I went a little crazy making it. It was a little messy. What is the independent variable? So we already answered that. We said that is number of hours of study. Okay, what is the dependent variable? Grade. When in doubt, use the same language the question uses. What is an appropriate title? I think that using a phrase like this to steer you in the right direction will definitely be a good idea. Grade based on number of hours of study. Grades as a result of specific number of hours of study. Okay, so let's say maybe grades based on or caused by something along those lines. A certain number of hours, very long title, of study. But you want to state the obvious, you know? What was the average grade earned? Well, you would want to make sure that you interpreted their understanding of average correctly. And maybe there was only one person who studied for 0 hours and got a 20. There were 2 people that did this. There were 25 people that did that, whatever. In that case, the average would not work as easily. If we were just using, you know, as if these each appeared once, you add them all together and divide by how many. So we have 1, 2, 3, 4, 5, 6 grades here. And if I added these all up, I would get 100. 80 and 20 is another 100, so that's 200. If I did 90 and take 10 from here, that's 300. I have 60 and 60, that's 120, so it's 420 divided by, we have 1, 2, 3, 4, 5, 6, so 420 divided by 6 is 70. So I'm assuming these are percents. You know, we can't be sure because the graph didn't really say so, so you don't want to go above and beyond and over generalize or assume anything, okay? And that's the end of that. Here in this next example, we have some more information. We're asked for a line graph. We want to label appropriately, and we want to figure out what depends on which. So temperature and enzyme activity. I mean, unless an enzyme activity is causing some sort of a temperature increase, which is possible, I'm going to kind of oversimplify and say that the temperature is going to be our independent variable, and the dependent is going to be enzyme activity. It depends on this. usually, and not all the time, but usually I feel that I notice that the independent variable, the one that goes on the x-axis, depending on the circumstances, is usually spaced out more nicely and consistently than the result, the dependent, the output. Okay, this could be very sporadic, and this could seem to have a little bit more of a rhythm, rhyme, or reason to it. So I'm going to sit and set up this graph, and I'll be right back. I just want to pop back in for a second and kind of talk about how I decide to set up my axes. So over here, if you see, I counted 2 boxes, and I made that 10, 20, 30, 40, 50, 60, 70. So like, how does somebody really decide? Okay, well, I'm going to look over here, and I see that my lowest value I'm going to use, my minimal enzyme activity, looks like it's 0, and my maximum is 20. I always try to use up all my axes. So I'm going to count how many boxes I have before I decide how I will count each box. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So, okay, I could really go up to 20 if I extended it. If you pay attention over here in the last example, see that I need to go to 100. So I kind of wanted to space it so I could really fill up the graph. I don't want some dinky, tiny little graph. I really want to get a good interpretation of it. However, I just said want to get a good interpretation, that this is important that you pay attention to things like this when you're looking at like newspapers or news articles when they share certain statistics, because they can mess up their graph a bit and be very misleading with their information. So you do really need to watch out for those things. So people can stretch or compress values and make things look like a bigger or smaller deal than they really are. But I'm going to go ahead and label this, and I'll be right back. Okay, so I have plotted, essentially it looks like a scatter plot in a way. I just have a bunch of random points here. Hopefully I was neat and accurate, and now they asked for a line graph. So I'm just going to connect them with a straight line. You don't want to draw a curve, okay? A line is straight. So I'm going to make a line graph, and I tried to make these points heavy and dark by putting, it's not my best, but sorry, by putting the independent variable and dependent variable here, it's easier to analyze this data and to see what's going on. It looks like as our temperature gets warmer, as our temperature increases from 0 to 20 degrees, and then from 20 to 30 degrees, and then from 30 to 40 degrees, then we drop over here when we get to 50 degrees, 60 degrees, and 70 degrees, right? So you can see that your enzyme activity is at what appears to be a maximum at 40 degrees. And the activity reaches 20, and then when it gets too hot, it looks like your enzyme activity comes down. So by having it graphed this way, you can see an increase and a decrease by how our minds interpret information. It just makes the graph more useful. If we graphed it the other way, I wish you could kind of see if this was transparent, but if we graphed this the other way, if this paper was see-through, okay, this would be my y and this would be my x. So really your graph, if you could imagine seeing this sideways, would really be more like this. It would still be here, and it would go up and then come down that way, okay? How do you interpret that? This is something we can wrap our minds around, okay? So you really want to make sure that you're graphing things on the right axis. You want to make sure if you're analyzing something, it really should be a function, right? That one would not have been a function. This passes the vertical line test, so definitely helpful for us in that sense. What is the independent variable? That would be temperature. And again, this table does not specify if it's degrees, Fahrenheit, or Celsius, so I'm just going to leave it at temperature, okay? The dependent, the thing that depends on the temperature, is the enzyme activity. And what is the appropriate title? Enzyme activity at different temperatures, something like that. Enzyme activity at different, probably shouldn't use symbols in your title, temperatures. Okay, sorry, a little messy. Okay, now we are off to the second objective. The second objective is asking us to take a look at function notation. F, parenthesis, x, close parenthesis, is read, well, hopefully we all know. You've probably heard this phrase for a while, f of x, I'm even going to put little quotation marks over there. Now, in a lot of word problems, the word of is going to imply that we're going to multiply. So if someone ever said half of your salary, well, how could you really represent such a phrase from a word problem? Half is quite literally half of, and then your salary, you could either put in the number, or you can maybe use S for salary. You might have to write somewhere on the side, let S equal a person's salary. There's no multiplication here whatsoever. That is not multiplication. This of is not implying multiplication at all. It is a notation. The x is almost more like a subscript. In physics, you may see something like v sub 2. That would mean the velocity after 2 seconds. The mathematical way that we represent that is v of 2, the velocity at 2 seconds. Okay, subscripts really don't work out well for us when we're in high school algebra over here, because the subscripts, superscripts, everything turns into the same size, even the index inside of a radical, and numbers just make a big mess. So we have a special notation that we use. It's just a sort of a footnote, the velocity at 2 seconds, for example. The variable inside the parentheses x is the blank variable. Hopefully we remember from just a few minutes ago, it is the independent. Okay, the value of the function, f of x. This is a package deal. It's sort of just stuck and glued together, okay? You cannot separate them. F of x, it's f parentheses x. You're just going to stick it all together, which could also be called y. And I know a lot of people kind of like really hold that near and dear to their heart. Represents the, well, context clues, dependent variable. Okay, next statement over here. F of x is the standard way of naming a function. So we default to that right there. Just like we use x and y for our main variables. And when we add a third axis, we do 3D, we use z. When we did angles and sides and things like that in geometry, we mostly did A, B, and C. However, functions can be named using any letters for the variables. You really could use whatever you want. I mean, I've used capital X of X before, okay? I've done lots of different things. When we are studying three functions at the same time, we might call them f of x, g of x, and h of x. I can even call this phrase f, g, and h of x, almost the way you would use a last name, so you don't have to say the same thing over and over again. All right, here, sometimes we use specific letters. This is going to help you out a lot to avoid mistakes for the variables to remind us of the problem. So, for example, volume of a sphere as a function of radius. Well, some of you might have to look up volume of a sphere, and some of you might remember that volume equals 4/3 pi r cubed. Volume depends on how big the radius is. This is a function of radius, of x. So I can write v of r. Whatever letter's in here will be the letter on the other side of my equation. That variable should be the only variable on that side. So v for volume and r for radius. Okay, v and r. Wages as a function of hours worked. So maybe we use W for wages and we use maybe H for hours worked. Well, that would be W of H. But we don't stop there. They gave us some more. Earning $8.25 per hour. This is sort of like miles per gallon, dollars per hour, except our units for dollars just happens to go in front of our number. Dollars per hour. If you were to graph this, based on what I said before, do you remember what goes on this axis and which goes here? Think about it. Dollars per hour, rise over run. Rise over run. Got it? And then X is what goes inside here anyway. And hopefully we get that it's 825H because you take your hourly pay and you multiply by the number of hours you work, okay? Salary as a, okay. Now, what if I use a big S for salary as a function of, I wouldn't recommend this, little s for sales. One, I don't like using S because it looks like a 5. And two, I just feel like this would be a complete disaster. But you can use whatever letters you want. Just make sure you write it down, okay? So with a base monthly salary of $2,100, you make that money no matter what, plus, well, it probably means addition, 15%. We have the symbol percent. It really means 15 for every per 100. There's your rate right there. There's that per. Sort of hidden though. 15% commission, and that's another conversation for another day. We could save it. Commission on sales. So if you sell $1,000 worth of merchandise, you're going to make 15% of that $1,000 into your next paycheck on top of what you make right there. 0.15 times 1,000. Again, percents I'm saving the lesson. I'm not going to go into all this here. S of little s equals. Now my base pay, 2,100 plus 15%, which is 0.15 times little s, the dollars of sales. Okay, I know there's a lot of different ways we could talk about percents and all this, but for right now, that's good enough. Another thing, the equation here is actually linear. Sorry, I didn't squeeze it over there. This is a linear equation. It is in slope-intercept form, which is the one you're probably most comfortable with from earlier years. Y equals mx plus b. It's just turned around. My b value is 2,100, and my m is 15.15, or which is 15 over 100. Up 15 for every 100. You get $15 for every $100 you sell. All right, and now we're on to evaluating functions, which I believe I did in blue. Okay, so evaluating functions. By definition, the blank variable, usually denoted by blank, varies or is manipulated to give outputs. So independent and x, okay, gives the outputs, which are the y's. When we want to calculate the value of a function for a given input, okay, given input, we indicate that by writing the input value inside the parentheses in place of x, okay? For example, as I fill in the blanks, for example, if f of x equals negative 7x plus 17, so we have an equation, so I'm just filling this in, independent and x. F of x equals this right here. Then to find the value of the function when x equals 3, you basically get rid of x everywhere it is. F of blank equals negative 7 times blank. So everywhere I had an x, I'm going to have a big blank space now. And what goes in there? Whatever you want, but wherever you put there, you got to be consistent. So if I'm using x equals 3, okay, It's like your quarterback got hurt. You have someone else who could play that position. You're going to fill them in instead. If x is equal to 3, they play the same position. I can fill it in. F of 3 equals negative 7 times 3 plus 17. I'm just going to extend this line, show a little bit more work than that. That's going to end up being negative 21 plus 17, which is going to be negative 4. Now, I would even say it's more important than you may realize to really write down f of 3, sorry, it kind of looks capital, equals negative 4. This is a full thought, a full idea, okay? This right here is my x value, and this is my y value, but this whole thing represents my y value, which could get a little confusing, okay? So for each of the following functions, evaluate. We have to find f of negative 2, negative 1, 0, 1, and 2. So f of x equals 4 minus 2x. And I want to find the f of negative 2. That means I'm going to fill in a negative 2 to every available opening. Sometimes you just have one, and sometimes you have several. So negative 2 is going to go right inside here and here. F of negative 2, I'm going to write again. Okay, I'm going to drop that down every step of the way. 4 plus 4, so f of negative 2 equals 8. What does that mean? When x equals negative 2, comma, y equals 8. I'm going to write each of these in a different way to kind of highlight, no pun intended, function notation and how useful it can be, okay? So that one is all right now. I'm going to go on to the next one now. This next example, f of negative 1, okay? So f of something, it was x left, it's gone, 4 minus 2 times x. So if x left, it's usually f of x, an x value has to go in there, and the new value I'm filling in is negative 1, negative 1. So f of negative 1 equals 4 plus 2. If you are not good with your positives and negatives, you got to make time to practice those, okay? I'm just going to scribble that out. F of negative 1 equals 6, okay? So this is my input. Oh, I'm running out of paper, out of screen over here. And that answer is my output. Okay? And then over here, I'm going to write 8. Over here, I'm going to write 6. And have that all written for us, okay? Next example. So I don't really love, like I said, squashing it horizontally. It's not really the best way to do it, okay? Okay, so there are a couple more examples. I'm not going to show the work for those, but I will show the answers. Okay, so here are all the answers, and if you need to pause it here to kind of look at the work and see if you got the same thing, then please do so. And if not, if you're confident, then we can just move on to the next part. Okay, down here, we are now going to be given a function graph, and we're going to ask to evaluate in 2 different ways. And this concept haunts students all the way through calc. Sometimes you're given the slope of slope of a curve at a certain point, and you have to find out what point causes that slope. And other times you're given a point, and you're asked to find the slope at that point. And it's not talking about slope of a line. We're talking about slopes of curves. And students jumble this kind of stuff up all the time. So I'm going to look at the x's as being yellow right now, okay? Do a little color association. This is saying g of x. So when I say f of, you say x. That should automatically be happening in your head already. F of, you finish the thought, you say x, okay? So whatever letter, number, anything that goes inside of the parenthesis after the F or the G or the H or whatever letter we might be using, keep in mind that that is going to be representing our x, our input, our independent, our x value right there, okay, on our horizontal axis. Now, they're saying evaluate. This doesn't say solve. This doesn't say true graph. It doesn't say simplify. G of 2. So that means when x is 2, what is our graph giving us? Okay, so my graph is really graphed in blue, and we mentioned earlier that they're really asking us for the y value of the graph there. So if I kind of go up, I'm not going to draw it solid. I'm just going to draw a dashed line right there. This is the point we're dealing with. At the x value of 2, I'm up here, there, and what value am I talking about? That one. So your answer for the g of 2 is going to equal 4. Okay, so how would I even articulate this? Is it worth writing down? You betcha. When x equals 2, the output, g of x, will become g of 2 is equal to 4, which is also the y value, okay? I don't know how many different ways. Ooh, I totally cut that off while I was writing. I'm sorry. Okay, so when x equals 2, comma, the output, g of x, which becomes g of 2, is equal to 4, which is our y value, okay? Now, the next part over here, though. Over here, solve g of blank equals 2. So now it's sort of in the other way. They want to know when the y value is 2, which x value had caused that to happen. So I see the spot. I see it right over here. So what point are we referencing? So it's the other one. So I would say that this happens when x equals -3. Really take your time to let that sink in. Really think about it, okay? So how can we maybe articulate that idea? Well, the y value of 2 occurs when x is equal to -3. There's my solution. So I'm interpreting it from a graph. Don't underestimate how important it is to write these phrases out. In a couple of weeks, when you don't remember, you'll have something to look at. So these will be a little quicker. F of 4. And of course, it's easy now because we're doing it right now, right after we just did 1. My answer is 2, the y value. And then what x value gives me a y value of 4? Which x value is that? When x equals -3. Coincidentally again, but I sort of have a bunch of random phrases all sort of cut out and laying on the notebook here. And I'm just going to kind of open them up and we're going to kind of line them up side by side and decide which goes with which. So it's kind of like the little kid game where, what was it, like Old Maid or something, where you had to match things together. So we're going to kind of figure this out. This is my first time doing this. I just randomly cut these out off of something I printed from a website. And we're just going to set them all up and I'll take them down into the notebook just so you could see a few examples of different potential word problem topics or things that depend on one another, just to make sure we're a little bit more comfortable with the concept, okay? So sorry, it's a bit of a mess, but let's see. I see a couple that I could already do. I already see right away f of x, my output over here, f of x depends on x. So that will definitely go on that side. Now, I also see the phrase dependent variable, and I found over here, or we have independent variable, okay? So dependent, independent, f of x and x. So if I see any other equation ones, that would be nice. Ooh, I see the word output. So the output is right over here, and there is the word input. Okay, so cell phone bill, cost of a ticket, number of hours at the beach. Okay, ooh, here's one. Maybe they go together. Cost to rent an umbrella depends on the number of hours at the beach, right? Number of, okay, cost of a ticket. Ooh, how about this? Cost of a ticket, this is not a concert ticket, depends on how fast you were driving, right? If you were going a lot over the speed limit, your ticket price cost might end up going up quite a bit. Number of hours the on switch is activated, number of touchdowns, battery life. Ooh, maybe that. Battery life depends on number of hours the on switch is activated. I see range. Range goes with Y, so I'm assuming we're putting it there. I see domain, so that must go right here. Okay, what else do we have? Score of a football game. I think I saw something to do with the number of, oh, here it is, touchdowns. So score of a football game depends on the number of touchdowns. Probably also the number of field goals, but we're going to keep it a little simple for right now. And what else do we have? Squashing all these, push them up a bit so I can keep them all on the screen here. Okay, cost of a ticket, how fast, battery life, on switch. Range depends on the domain. Score of a football game, number of touchdowns. Cost of fruit depends on how many pounds of fruit we buy. So here are these two. I'm just going to kind of stick these right over there. How much math you master. Cell phone bill? Probably not. How much math you, actually, if your parents cut off your cell phone bill, you'll probably master more math. So how much math you master depends if your parents cut off your cell phone or not. Ooh, grades on a test. This seems, your grades on a test depend on how much math you master. There we go. Weight of a patient, number of paint cans I see, surface area of a fence. Oh, okay. Number of paint cans you might buy at the store depends on the surface area of the fence that you're painting. Number of minutes used, cell phone bill. Okay, so your cell phone bill might depend on, squeeze it over here, number of minutes used. Number of, how much weight you can lift depends on, sorry, I'm just throwing it everywhere. Number of bicep curls you do, number of bicep curls you do daily. And the weight of a patient, amount of cough syrup. Okay, the amount of cough syrup someone has to take Depends on the weight of the patient. So there's a lot of different things that we can use this situation for. You're going to have to be responsible for writing a lot of word problems in the future. So hopefully this helps clear up a lot of confusion. All right, the last extra thing I really just want to go over is bonus example. What if I was given something like f of x is equal to x cubed minus x squared? And what if I asked you to determine the f of x plus h? What do you think that equals? Now I'm going to stall for a minute so you can think, so you can write, so you can catch up. But it can't be that easy because it's a bonus example. You're not just going to stick plus h at the end. You really need to think about what we have been talking about. F of x is equal to x to the third minus x to the second. And now they're asking us to change it up. Instead of us having to just keep f of x, what if I need f of x plus h? Well, what do I do? So I'm going to kind of insert a little bonus step. Now, I would really rather, obviously, you guys pause and really just try something, write it down, and see if you get the right answer, okay? If you paused and came back, or if you choose not to pause, I'm going to show you a little something now. I'm going to leave it f of blank equals. So I'm basically going to erase out everything that's written in the yellow space. Now, could I go ahead and, I'll even write it for now. Equals, I'm going to make the parentheses a little bit roomier, okay? X to the third minus x to the second. So it really is the same equation. But I'm going to go over here and I'm going to erase the x because I'm replacing it. I'm swapping out x for something else. Everywhere I had x, okay, I'm going to fill in some new value. It's going to go everywhere x was. Now, sometimes you might be able to leave it just subbed in and not even expanded or tinkered with at all. Sometimes you will have multiple choice questions where you can just sort of leave things as they are. But in this case, I'm going to go pretty far into simplifying this situation. So everywhere I have this blank spot that was yellow that I'm swapping out for pink, I will write x plus h to the third power, or cubed, minus, these are called, you could say the quantity of, minus the quantity of x plus h squared. Now, while that is correct in itself, the way it's written, we would like to practice right now to get us ready for the future. If you plan on taking pre-calculus or calculus, you'll see this again. It will come up, okay? We're going to expand this a little bit more. Now, again, it's not easy. This is not, I promise you, this is not x cubed plus h cubed. And I promise this is not x squared plus h squared. This is not how you cube or square or take the square root of a sum or a difference. To cube means to multiply something by itself 3 times. To square, you multiply something by itself in 2 pairs, okay? X plus h and x plus h. You got to do it the long way. There are shortcuts that you can learn in algebra, but right now I'm going to do everything else the long way. If you don't know your properties of exponents, you're going to have a hard time multiplying. You're going to accidentally write weird things like 2h or 2x. You're also going to potentially mess up distributing this negative. There are a lot of places where basic fundamental algebra skills can really mess up your entire problem. xh plus xh, also you have to know how to add versus multiply. That's going to be equivalent to 2xh or hx, whatever you want to call it, really the same. X squared. Parentheses, brackets, doesn't make a difference. I already did this once, so I'm going to go ahead and plop that right in there because I already know what it is. Really, I like it in alphabetical. I feel like I should have written hx, but now here, something maybe we haven't done much yet, but let's talk about this. I'm going to distribute. I'm going to distribute x to all 3 places. Then after that, I'm going to distribute h, again, to all 3 places. So to 1, to 2, and to 3, okay? So now I'm going to do h. This will become h and x squared, so it's going to go right there. That's going to be 2xh squared. So 2xh squared, I'm going to do a little vertical action so it's easier to combine like terms, plus h to the third, minus, I'm going to distribute that minus sign throughout. I'm going to get minus x squared. I'm going to get minus 2xh minus h squared. And now I'm going to just combine the few like terms that I have. So I think this is a really cool example. Maybe it's something you would see as extra credit, and it's definitely something you would see in the future if you continue with math. And I just sort of went in, I accidentally wrote x squared there, so I just took a second to change that to x cubed, and I hope that this helped you guys strengthen your abilities in this section.